Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about a Leetcode question number 120. So triangle. Given a triangle array, return the minimum part sum from top to bottom. If you already saw my video on minimum part sum or you have already solved that question, then try to solve this question also, because it is a similar question to that with a slight change, where there you will be moving towards the right and down, but here you want to move. For each step you may move to the adjacent number of the row below. More formally, if you are standing on ith position on the current row, then you must go to the next row's ith position or I plus 1th position. Can you understand this? So this is the reason why I am again telling you, if you not watched my video on minimum part sum, just go and watch it and try this try this problem by yourself. I'll be giving that video link in the description. Okay, fine. Now, if the triangle is like this, okay, so this is the input triangle, then I'll be telling you my output will be 11, because I'll be first starting from this 2, then 3, then 5, then 1. That's it. Simple. Can you understand this? Okay. Now, what is the easiest approach we can use here? So that's going to be greedy approach. Why? Because we are focusing on minimum. Okay, whenever there is a word like minimum, maximum, so there we want to apply whether the greedy algorithm passes or fails. Okay, we want to see that, right? Okay, now initially I'll be starting from this 2. Okay, now from this 2, where I can go for this 3, or I can go for this 4, which is minimum. 3 is minimum, so go here. From this 3, I can either go to the 6 or go to this 5. Where I will go? I'll be going towards the 5. Okay, go here. Now from this 5, wherever I can go to this 1, or I can go to this 8. So I'll be going towards this 1. I understand this. Okay, now I have reached the end. Stop here. What is the cost? Cost is 11. That's it. Hope you understand this. Okay, so this is going to be the greedy approach, but this greedy approach fails on some particular examples. Okay, because it is not a uniformity concept, right? They may occur in any directions. Like for example, here comes 2, here comes 3, and here comes 4. Okay, or else fine. Okay, now here comes 10, here comes 11, and here comes 1. Okay, now I'm asking you to find which is the minimum path. Then you will be obviously coming here, choosing this 2 first, then 3, then this 10. Hats off our greedy approach. If you are taking like this, then the cost will be 15. But I'll be suggesting you to take, like, first take this 2, then take this 4, because we can take this 4, then take this 1, such that I have reached the last row using how many cost? It will be 2 plus 1, 3, 3 plus 4 is equal to 7. So 7 is the cost now, which is lesser than 15. So this is going to be the answer, right? The 7 is going to be the answer. Now hope you where the greedy algorithm fails. Okay, whenever the greedy algorithm fails, we want to go for recursion. Why we are going to for recursion? Because here in the recursion, we will be taking all possible combinations, right? So we are just getting into the all possible combinations, and we are just deciding which such combination is a minimum value. Okay, that's the reason why we are taking the recursion. Okay, always for recursion, first we want to focus on what is the function parameter, right? So what is going to be the function parameter? As you can see here, there are 2 indices, right? Everything is consists of 2 indices. Okay, so here also in recursion, it should be consisting of how many indices? 2 indices, going to be the varying parameter. For example, row and column. Okay, fine. Where should I start? I should be starting from the top, 0, 0. I should be starting from the top, 0, 0. So let me start from 0, 0. Okay, from this 0, 0, or else let me just quick a second give a small description about the recursion. Okay, now what is going to be the recursion? So see here, recursion is always assume we are having a big problem. We are going to divide it into a sub problem such that sub problem cannot be further divided into any other sub problem, and then giving the solution for that sub problem will be building a solution for the main problem. So this is going to be recursion, right? So this is your main problem. This is your main problem. Okay, how I am going to able to just go with the sub problems? So I can either go to the next row, same column. Yes, from this 2 to this 3, or I will be going to next rows, next column. That's it. Fine. So this is going to be your breaking points. So this is going to be your divide and conquer technique. Okay. Meanwhile, what is going to be a base condition? So when I reach the end, I'll be just returning 0. That's it. So my base condition is when my row reaches the end, n is going to be the length of the this matrix. Okay. If row is equal to n, then what should I do? I'll be just returning 0. That's it. So this is going to be your base condition. I can tell you that like that, right? Fine. Now let us get into this. So initially, let me write this 2 3 4 6 5 7 4 1 8 3. Okay. Now initially I will be starting from 0 comma 0, right? 0 comma 0. Okay, from this 0 comma 0, where I can go? I can either go to f of, okay, go to the next row, not increasing my column, or else go to the next row, increasing my column. So these two are the possible conditions, right? Now again for this f of 1 comma 0, here I can either go to f of, just a minute, I can either go to f of 2 comma 0, or I can either go to f of 2 comma 1. Here similarly I can either go to f of 2 comma 1, or I can go for f of 2 comma 2. Fine. Now again for this f of 2 comma 0, for this f of 2 comma 0, again I can either go for f of 3 comma 0, or I can either go for f of 3 comma 1. Yes, similarly here I can either go for 3 comma 1, or I can either go for f of 3 comma 2. Here it will be f of 3 comma 1, or I can go for f of 3 comma 2. Here similarly I can go for f of 3 comma 2. Meanwhile here I can go for f of 3 comma 3. Again for this f of 3 comma 0, I can either go for f of 4 comma 0, or I can either go for f of 4 comma 1. Now observe this carefully. What is f of 4 comma 0 represent? It represent go to the 4th in this row, 0th in this column. Can you understand this? So which implies we have reached the end. At this point I will be returning what? 0. Here also I will be returning 0. Similarly here there are two things. What are them? They will be f of 4 comma 1 and also 4 comma 0. Everything here will be returning 0, right? Everything will be returning 0 here. Okay, can you understand this? Here every recursion calls next to this will be returning 0 only. Now hope you understand this. Now from this 0, what should I select? Okay, it is a minimum path. So what should I select? I should be selecting the minimum value. So from this 0, what is the minimum value? 0 only. So 0 plus what is 3 comma 0's value? So 3 comma 0 means it is 4. So 0 plus 4 which is equal to 4. So 4 will be returned here. Similarly here 0 plus what is 3 comma 1? So 3 comma 1 means it is something like here. Yes, 1. So this will be returning 1. Can you understand this? Okay, now what is 3 comma 1 here? So here also it will be two recursion calls and they both will be returning 0. You can understand that, right? Okay, now 0 plus what is 3 comma 1? 3 comma 1 is 1. So here it will be returning 1. Meanwhile here 3 comma 2 which is equal to 8. So 0 plus 8 which is returning 8. Okay, now meanwhile here it will be 0 plus 3 comma 1. 3 comma 1 means this 1. So 1 will be returned. And here also similarly it will be 0 plus 8 which is equal to 8. Here it will be 0 plus 8 which is equal to 8. Here it is 0 plus 3 comma 3 is what? 3. So it will be 3. Okay, now from this whether 4 is small or 1 is small, 1 is small. So 1 plus what is 2 comma 0? 2 comma 0 is 6. So this will be returning 7. Okay. Meanwhile, here, what is the minimum? Minimum is 1. 1 plus what is 2 comma 1? 2 comma 1 is 5, right? Okay. 1 plus 5, this will be returning 6. Okay. Okay. Now, similarly here, what is the smallest thing? 1. Okay. Now 1 plus what is 2 comma 1? It is 5. So this will be returning me 6. Here, similarly, 3 or 8. So 3 is smaller, right? So 3 plus what is f of 2? It is 7. It is 7. Okay. Now it will be returning 10. Again, now whether 7 or 6, which is smaller? 6 is smaller. So 6 plus f of 1 comma 0, 3. So this will be returning 9. Okay. Similarly, here 6 or 10, which is smaller? 6 is smaller, right? So 6 plus f of 1 comma 1, which is equal to 4. So this will be returning 10. So 10 or 9, which is smaller? 9 is smaller. 9 plus what is 0 comma 0? It is 2. 2, which is equal to 11. 11 is our required output. Can you understand this? So they didn't ask you to find the minimum path. They are clearly stated that we want to find minimum path sum. There is a huge difference between minimum path and minimum path sum. Okay, that's the reason why we are only returning the values which is giving me the minimum. So now hope you understand what is meant by recursion, right? So here itself you can understand the recursion. We are having a big problem. We are subdividing into a sub problem such that minute problem cannot be further divided into a sub problem. For that only we are having a special term called base condition, and that base condition will be returning some value and keep on returning some values until that main problem have a solution. Okay, fine. Now tell me, what is the time complexity? So the time complexity, I can tell you that it will be O of n cross n or n square. Okay, and space complexity will be O of space complexity only n square. Okay, here it will be 2 power n square. Meanwhile, space complexity will be O of n square. Okay. So here you may ask why it is 2 power n square at the worst time complexity. You can clearly see here. We are starting from one recursion and we are dividing that recursion into a 2 sub problems. For n square, it will be obviously 2 power n. So this is going to be your worst time complexity, and space complexity is because of the recursion stack, the auxiliary stack. Fine. So let us see the code, then we can proceed with the optimization technique. So see here, this is a Java code. If you want the C++ or Python code, just go and find in the description. Okay, fine. So see here, this is going to be the main function's body. Here I have taken the n value and I have just centered the helper functions as an argument. Okay, fine. Now going to the helper function. So path. So here, what are the parameters we are using? Row and column. So these two going to be the varying parameter. That's the difference between varying parameter. See here the n and triangle won't be changed according to the recursion calls, right? But this row and column will be changing throughout the recursion calls. Initially it will be 0, 0, then it will be 0, 1 or 1, 0, like that. Can you understand this? Okay. Now row is equal to n. Okay. Then return 0. Then return 0. Okay. Fine. Now down is equal to, I want to take triangle dot get row dot get column. Okay, plus I want to go to what? Row plus 1, but column remains same. So this is going to be your down. For your diagonal, same thing, but the only change is row plus 1 and column plus 1. That's it. At last, I'll be just returning the minimum. You can also remove this and this. Okay, and here you can put them all together one time. Okay, which means, hey, take myself as one of the path and take the minimum among my down and my diagonal, merge it, send it. That's it. Can you understand this? Okay, so this is going to be a recursion. If you submit this, it will be not submitted successfully because we want to optimize it. Why? I will be telling you just a minute. So see here, what is the input size? See here, this is the input size. It is 200. In worst time complexity, it will be of 2 power 200 square or it will be 2 power 200 itself. Okay, 2 power 200. 2 power 200 is greater than the 10 power 9, the clock time, the running time of our program. So that's the reason why it not be submitted successfully. Okay, so what is our next approach? It is going to be the memoization. So memorization is simply using a term like memory. We are going to store in memory such that when it is again occurring, we are just taking that computer value and returning there itself. Okay. For example, see here 2 comma 1, here also 2 comma 1. As you know already, our recursion is a DFS, the first search, which means it will be starting from here, going up to the depth, then returning up, then go to the depth, then returning up, then go to the depth, then returning up, then go to the depth, like that. It will be like this only, right? So from this, I can tell you, first this 2 comma 1 is computed. The 6 is computed at first. Okay, then only it will be next going to this recursion call, and just this will be computed. Understand this? Okay, if I already store this 6 in my memory, then I don't want to go for these recursion calls. Instead, I can directly send this 6 up, the return value, right? So this is going to be the memorization technique. Okay, so it's very simplest form, so you can easily able to understand this. Okay, come up with me. There are some few steps to do this memorization technique. First of all, what we want to design a memorization matrix, or you can able to do in a hash map, but my kind request is able to learn the array or matrix form. Okay, hash map will be helpful for some cases, but this array method or the matrix method will be very useful upon optimization. Okay, so see here, we can do this using the hash map and array. I'll be doing this using the array. You want to try this using the hash map after watching my array explanation. Okay, fine. So the first step is we want to design that array. Design that array makes sense, like what is going to be the initial value, what is going to be the size of the array. Okay, now let us take an array. Now in this array, what is going to be the dimension of this array? That's going to be the first point. See here, there are two varying parameters. One is row, another one is column. So from this, I can tell you our array is going to be 2D. Can I understand this? Because we have row and also column, which means it implies, hey, I am 2D. So take 2D array or matrix. Okay. Now in this, what is going to be size of the array? So see here, row is starting from 0 and ending at where? Ending at n. Similarly, column also starting at 0 and it also ending at n. So from this, I can tell you this is going to be n cross n matrix. Can I understand this? So this will be starting from 0 and going up to n minus 1. For example, we have already saw example, right? So here there are totally of 4 rows, which means here also it will be 4 rows and 4 columns. Then here also it will be 4 columns. So this is going to be my matrix. So this is going to be your first step. Now the next step is, what is the value I want to initialize inside of this? Okay, so this is much trickier than you think, because see here, in problem statement they have clearly stated that, see here, minus 10 power 4 up to 10 power 4 they have given some values. So you want to frame or you want to initialize some value that will not be encountered when in the return statements. For example, you can take all the values as null, or you can either take as minus infinity, or you can either take as infinity. That's your wish. Okay, here I will be taking as everything as infinity or into max. Okay, everything is infinity. Okay, fine. So this is the first step. The next step, the second step is, just understand this. Here we want to give one more line. What is that line? If for example this is a DP, this matrix name is DP. Okay, now if DP of row and column, okay, is not equal to the infinity, then what should I do? I'll be just returning DP of row and column. That's it. Okay, so this is one more line you want to add, and here before returning it you want to just initialize it, then return it. Okay, so DP of row and column is equal to minimum among the down and the diagonal. Okay, then return it. Return DP of row and column. So That's it. So it is memoized. I want to tell you what these lines means, right? Now, see here, in these two lines, we are just updating our matrix. We are just updating our matrix. In these two lines, we are checking whether it is computed already. If it is so, why I want to again go and compute it? Just return that value. Now, hope you understand what is memoization means, right? Now, tell me what is the time complexity is reduced to 2. So it is reduced to n square, and space complexity now is n square. Okay, and the space complexity is because of, one is because of our matrix, and next is because of recursion stack. Can you understand this? How far our time and space complexity is, our time complexity is reduced, right? So it is reduced from exponential to a quadratic or a polynomial, right? So this is a vast change. Fine. So let us see the code, then we can continue with the further optimization. So this is going to be a lengthiest video because I want you to understand this problem entirely. I don't want you to understand the overall concept. I want you to understand the depth. Okay, fine. Now see here. The first step is I want to design the matrix, right? So it is going to be of 2D array, and it is going to be of n cross n, and it is going to be of all values equal to int max or infinity, or you can take minus infinity also, but all values should be same. Okay, you can take minus infinity, you can take some other values which will be not returned, and it is guaranteed that it will be not returned in any particular return statements of the recursion call. Okay, fine. Now the next one line we have added is this line. Okay, similar to a drawing explanation, and the next line is like this. So in Java you can add like that, but in Python you cannot do this, right? That's the reason I either just give one like, first I will be updating in my matrix, then I will be returning the matrix particular index. That's it. Okay, now if you submit it, it will be submitted successfully. So the next optimization technique is a tabulation. So in memoization, we got the space complexity as O of n square because of what? Because of two things. One is matrix and another one is recursion stack. Now we are going to eliminate the recursion stack. How we are going to eliminate the recursion stack? It is simple. We want to don't use the recursion. Instead, we will be using a looping. So how we are going to use the looping? See here, the first step is what the matrix we have used in the memoization. We have used we have used a matrix like this for an input of row is equal to 4. If they have given the row is equal to 4, then we have 4 cross 4 matrix in the memoization, right? Now in tabulation, we want to alter this using some base conditions. So what is the first base condition? If row is equal to n, then I want to return 0. So if row is equal to n means if row is equal to 4, then I want to return 0. So I want a index number 4 in my row. Whether I have anything like that in my matrix? No. So I want to add another row here. Okay, and initialize everything as zeros. That's it. So this is the first thing. And the next thing you want to observe in this particular problem is, see here, row plus 1 and column plus 1. Okay, so this step, many of them will be doing a mistake. I will be coming to the next time. I'll be coming to the afterwards. Okay, now let's just construct this. Okay, I'll be telling you what are the mistakes we will be doing. Okay, fine. So let us just strike out this line. We don't want this line anymore. Now here, this is the body of the recursion, right? Whenever we have encountered the body of the recursion, put a loop. So for row will be from where? Will be from n minus 1 to 0. You may ask, hey, why n minus 1 to 0? See here row is starting from 0 going up to n minus 1. Row will be going up to n minus 1. When it reaches n, it will be returning 0. So I'll be just starting with n minus 1 up to 0. Whenever we are having a recursion code like from starting from 0 to n minus 1, in my looping, I will be changing from n minus 1 to 0. Understand this? Similarly for column, what will be putting? We'll be putting n minus 1 to 0. It is absolutely wrong. Okay, why? Because see this carefully. Our column will be always less than or equal to the row number. Yes. So what is the triangle they have given? They have given a triangle like For example, they will be giving a triangle like this only. So here this is the first row and this is the first column, and this column number won't be exceeding the row. You can see in this example, right? So for this reason only, I'm telling you that if you are starting from n-1 to 0, it will be wrong. Instead, we want to start from row up to 0. Can understand this? Okay. Now, what is the next line? What is the body of the recursion? So the body is, first of all, down. So down is equal to triangle of row and triangle of column plus, here comes the path. Path means is the recursion call. Instead of recursion call, take dp of row plus 1 and column plus 1. Okay, that's it. Because they are the two which are changing parameters. Right. Now, similarly here also, diagonal is equal to triangle of row and column plus dp of, here path, it will be changed into dp, the memoization matrix. Okay. Now here comes row plus 1 and column plus 1. Similarly here also, row plus 1 and column plus 1. Okay. Similarly here comes dp of row comma column. So here dp of row and column is equal to minimum of down and diagonal. That's it. Okay. Similarly, what you are going to return after doing everything, you want to return 0, 0. So just return dp of 0 and 0. See here we are returning what? Path of 0, 0. Similarly here also dp of 0, 0. That's it. Okay. Now we are doing a kind of a small mistake. What is that mistake? See here, if I am standing at this particular point, let me change the color. Observe this orange color. Okay, I am standing at this point. Okay, now I can either go to row plus 1 or I can either go to row plus 1 and column plus 1. But here it is out of range. Can you understand this? So for this reason only, I have told you I will be lastly demonstrating a mistake we have done. So for this reason, I will be adding one more column. Okay. And this column will be having everything as zeros. That's it. Because here 0, okay, or this column will be not initialized. That's your wish. Okay, I'll be having a 0 here as of now. Okay, when I am standing, just observe the orange mark. When I am standing here, I can go down or I can go diagonally. Fine. So this is fine. I will be taking a 4 cross 4 matrix. 5 cross 5 matrix, and I'll be filling all the last rows as 0 as I have mentioned in the base condition. And I understand this, why I am putting another column here. Okay, if you just dry run the code, then you can understand why I am putting this one more thing. Okay, fine. So I forgot to tell you what is the time complexity. So what is going to be the time complexity? So see here, the time complexity is going to be O of n square, and space complexity is going to be O of n square, but the space complexity only because of the matrix we have used, not because of the recursion stack. Fine. Now let us see the code. See here. First of all, I have done a mistake like, just a minute. Let me comment this. So this is the memoization code, right? Let me comment this. Now this is going to the tabulation code. If you don't put n plus 1 in your column, you will be encountering a mistake like this. Index 4 out of bound for length 4. Can you understand this? So that's the reason why I implemented you to put n plus 1 here. Okay, if you put like this, then just a minute. Yes, it will be running successfully. Yes. Now hope you understand why we are incrementing our row and column plus 1. Okay, so this will be entirely of your tabulation code. Now let us take this code and just optimize this further. So the optimization after this will be your space optimization. So fourth one is space optimization. So why we are going to do the space optimization? So it is because, see here, we don't want much space, like we don't want the complete matrix. We can do this in a simple way also, right? So that's the reason why we are using a space optimization. So see here, for everything we want dp of row plus 1 and dp of row plus 1. Okay, and here also you want dp of row. So from this I can tell you we only want 2 rows of n columns or n plus 1 columns. Can I understand this? So this is going to be your optimization. This is going to be your optimization. Okay, so let me just do the optimization so that you can understand this clearly. First of all, I'll be taking previous as n plus 1 column. For example, if the row is equal to 4, then I'll be having 0, 1, 2, 3 and 4. So 5 size. Okay, so this is going to be your previous and this is going to be your current. Okay, current will be also of 5 size. Okay, now I have taken two rows with n plus 1 column. Okay, what is the next step? So instead of this line only, I have mentioned these twos. Okay, now the next step is initialization path. Okay, so let us come to the body, because there is no initialization as of now here. Okay, because everything is 0, right, as of now. Okay, now come to this body, these two things, okay, will be as it is. Now these two lines will be having some differences. Sorry, these 3 lines will be having some differences. Like in this first line, instead of this dp row plus 1, I will be just writing like previous. Okay, and previous will be filled with zeros. Fine. And then instead of dp row plus 1, here also I'll be writing as previous. And instead of dp of rows, I'll be writing current. Can you understand this? After doing these things, here I'll be writing like, okay, now assign my previous as current. That's it. Okay, at last, instead of returning like this, I'll be just returning like previous. That's it. Or you can also return like current, because anyway they will be both same after this particular line. Okay, that's the reason why you can either return the previous or you can either return the current. Can I understand this? What I am doing here? See here, I only want 2 rows. So my previous row will be my row plus 1. And my current row will be the current variable. Okay. So once I completed the iteration, I'll be just initializing my current to the previous, such that in my next iteration, this previous will be useful. Okay, so this is entirely going to the space optimization technique. Now, what is the time complexity? So time complexity will be O of n square, but space complexity will be O of n, because we are only using 2 cross column plus 1, or 2 cross n plus 1. So this is the matrix size. Okay, so this 2 is the constant. So what is the only value we are using? N. So this is the space and time complexity for the optimized solution. Now let us see the code so that you can understand this clearly. Let me comment this out. Okay, now come here. So this is going to be your optimized code. See here, first of all, I'll be taking a previous as n plus 1. So this is the first thing, and then you can also take this current and initialize here, and also you can initialize here. That's your wish. Okay, now here everything else is same. The only thing is, instead of my dp row plus plus 1, I'll be taking previous. Here also dp row plus 1, instead of that I'll be taking previous. Instead of my dp of row, I'll be taking current, and at last I'll be initializing my previous as current. At last I'll be returning either previous of 0, or if you initialize this current outside here something like here, then I'll be returning a current of 0 also. That's your wish. Okay, so this is the whole versions of the optimizations of these codes. Okay, initially we have written the recursion, then memoized it, then tabulated, then at last it will be space optimization. So it will be helpful for you to just crack that technical HR round also. If you really like this video and subscribe to my channel, and if you can understand this, please comment below. It will be a great feedback for me. And if you have any doubts, just comment below. I'll be giving the answers. And if you want to know about these kinds of algorithms, just go and search in my YouTube channel. Thank you.